Assalamualaikum warahmatullahi wabarakatuh. Today we are going to discuss about our group assignment, which is QMT342, Fundamentals of Operation Research. This assignment we are going to execute a QE thoroughly, and we decided to do it at Point Bakery, Segamat. We also like to thanks to Madam Diana for her guidance to this assignment. So here are our group members. So we will move to introduction. So for this assignment, we decided to do at Point Bakery, Segamat. So it located at A008, Youth Central, Jalan Utama 3/2, Taman Utama, Segamat. So the operation time for this bakery is from 10 AM until 10 PM. The number of servers provided is 2 servers. So Point Bakery is a bakery concept focused on artisanal bread, pastry and dessert, built on the commitment to using only high quality, locally sourced ingredients, and it also frequently highlights a community-driven approach that effectively marries tradition with innovation to offer a whole gamut of both classic and contemporary baked goods. So for this assignment, we only calculate for one server only. Next, we move on the characteristic of the system. For the rival characteristic, we observe that the size of the calling population is limited or finite. The pattern of the arrival is random, with customers arriving at the shop according to specific time intervals. In terms of arrival behavior, customers pick up their food and patiently queue at the counter to either have it packed or order drink. For the waiting line characteristic, the queue length is considered unlimited, meaning there is no restriction on how many customers can join the line. The queue discipline follows the first in, first out, which is FIFO rule, ensuring that customers are served in the order they arrive. Lastly, for the service facility characteristics, the system operates as a single channel, single pay setup, where there is one counter and one stage of service. Customers arrive, wait in line, are served by the staff, and then exit the system. This simple yet efficient structure ensures smooth customer flow and manageable operations.
Next, we move to the calculation. In this our book project, we setting the time from 10:57 AM until 11:57 AM, mean 1 hour. And in this case, we have to find mu. So the first one, we have to find the average time of customer that their food being packed or drink order. Next, we have to find the average time of services per hour. First, we have to find the total service time. So total service time is n time minus arrival time for each customer. So the total is 39 minutes. Next is lambda or total customer. So we get 13 customer. After that, we have to find the average time taken to serve customer. Mean total service time over total customer. So we get 39/30 equal to 3. And lastly, we have to find the average time of service per hour. So we got 60 minutes over average time. So we get 60/3 equal to 20, or it will be a mu.
So our next step is we will open the QM and choose waiting line simulation, and then we will choose M/M/1 because we have only one number of server, and then we will enter the number of lambda, which is 13, and number of mu, which is 20, to the QM. This table provides an overview of the performance metric for a queuing system. Average server utilization is 0.65, meaning the server is busy 65% of the time, while the system remains idle for the other 35%. The average number of entities waiting in the queue is 1.21, while the total average number of entities in the system, including those being served, is 1.86. each entity spends an average of 0.09 minutes or 5.57 seconds waiting in the queue. The total time an entity spends in the system, including both waiting and service time, is 0.14 minutes or 8.57 seconds. The probability of the system being empty is 0.35, indicating that there are no entities in the system 35% of the time. This analysis highlights that the system operates efficiently with moderate server utilization, minimal waiting times, and a reasonable probability of being idle, which leave room to handle additional workload if necessary.
Next, this table provides a detailed probability distribution for the number of entities in the system. The column represents the probability of having exactly entities in the system, the cumulative probability of having or fewer entities, and the cumulative probability of having more than entities. When entities equal to 0, the probability of the system being empty is 0.35, which matches the idle probability from the previous table. The cumulative probability of having 0 or fewer entity is also 0.35, while the probability of having more than 0 entities is 0.65. As entity increase, the probability of exactly entities in the system decrease. For the instance at 1, the probability of having exactly 1 entities is 0.23. The cumulative probability of having 1 or fewer entities rise to 0.58, while the probability of having more than 1 entity is 0.42. Similarly, at 2, the probability of exactly 2 entity is 0.15, and the cumulative probability of having 2 or fewer entities is 0.73. By entity equal to 6, the probability of exactly entity becomes very small, which is 0.03. At this point, the cumulative probability of having 6 or fewer entity is 0.95, meaning the system is almost always below this threshold. Beyond equal to 9, the probability become negligible, and by the 13, the probability of having more than 13 entities is effectively 0. This table is useful for understanding the distribution of entities in the system, helping to evaluate the capacity and performance. It shows that the system is most often lightly loaded, with very low probabilities of experiencing a large number of entities at once.
So, as conclusion, is the numbers of the servers provided adequate? So, the average time of service is 3 minutes, while the average number of service per hour is 20 customers. So, are the customers happy with the waiting time? Yes, because the customer just need to wait 3 minutes to be served. And in conclusion, the system demonstrates excellent performance, balancing efficient resources usage with the ability to maintain low delays and a high degree of flexibility. It is well optimized for its current workload and provides significant capacity for future growth or sudden increases in demand.